Spring fans! In today's installment of Spring Tips, we're going to look at how to build applications using Spring Cloud Stream. In an earlier video, we looked at Spring integration, which is a way of building event-driven applications in a clean, consistent way. One thing that we saw in that Spring integration video was that message channels can be used to connect different components, components that are in the same virtual machine, or indeed components that are distributed, because you can have at the terminuses of these different channels adapters, and these adapters are one of the many types of components that Spring integration ships with. An adapter is meant to transform a Spring Framework message as it transits through a Spring Framework message channel into something that can be used in the outside world. So we could use Apache Kafka, we could use Zuki, we could use Redis, we could use Twitter, we could use email, we could use whatever. Anything you can imagine thinking about in terms of events or messages can be adapted into a Spring Framework message. So I can listen to messages or events from the outside world. I can say whenever a new email arrives in an IMAP server, IMAP idle supporting email service, publish a message. Or whenever a new message arrives on a JMS broker, publish a message, and then I will listen for the message at the end of the other side of that channel. So we have two things happening here. We've got a component that's monitoring the outside world, and as soon as it perceives an event, it publishes a message into that channel. And on the other side, of course, we have a component that listens to it. Similarly, we could have a component that publishes messages, something that takes a message or generates a message and then writes it out to an outbound adapter. In this way, the message enters the channel, and then on the other side we have a listener, an outbound adapter, that translates the message from Spring Framework into something that can be used in the outside world. Maybe translate the Spring Framework message into a Twitter message, or a file in an FTP server, or whatever, right? The number of things you can talk to using these adapters is myriad. And so Spring integration makes a very, very nice basis for messaging-based integration, right? This is the most durable way of integrating services, especially those separated by a network partition. Messaging offers a lot of benefits. It's temporally decoupled, that is to say, it doesn't matter if both the producer and the consumer are alive and awake and able to respond at the same time. I can write a message to a message broker, and as long as that broker has acknowledged the message and stored it durably, then the consumer can come along later on and then retroactively consume the message. So that's one benefit of messaging. It's also locational decoupling, right? I don't care as a producer of a message or a consumer where the message ends up or where it originates, right? I just care about where that broker is. So I can have as many different clients as I want, and they can live wherever they want, right? They don't have to be in a specific IP or location or anything else. All I need to worry about is finding that broker, and indeed that broker can scale out, right? So we can have as many instances of that broker as we need to, and to scale it horizontally. So it's very easy to say, I want to use multicast, or I want to use a ring to find a broker and then talk to it. Now, by working in terms of the message queue, we're forced to commoditize our interactions. We're forced to use a commodity sort of protocol, or payload rather, to talk to each other, right? So it doesn't matter if one system speaks Java and the other one speaks .NET and the other one speaks C, for example. They can all talk so long as they can talk to that message broker. So we've also now extended the reach of our integration to other different kinds of clients. This is different, for example, than what you'd get if you used RPC or something like that was technology specific. So we get a lot of benefits by using messaging that we don't get with synchronous RPC kind of interactions, such as you would have with, for example, EJB, right? So messaging is not a new idea, but it happens to be a really great fit for what we're trying to do in the microservices world, where everything really is just a distributed system, a different component. And messaging in particular allows us to talk to legacy systems that don't perhaps speak the same language as the one we're trying to speak. So integration, Spring integration in particular, is a great fit for that. But when we're trying to build modern microservices, we're not trying to integrate legacy systems, right? We're building systems and components in 2016 or beyond, and these components are probably going to be able to work in terms of JSON or XML or something sort of modern like that. They're probably going to support access to modern brokers, modern message queues, right? So we can take for granted that our messaging-based microservices today will have access to things like RabbitMQ or Apache Kafka or whatever, right? So in this case, we don't really need the full flexibility that Spring integration gives us. It's nice to be able to talk to any old system under the sun and be able to talk to it in terms of messages, but that extra flexibility comes at the cost of having to configure and specify the sort of adapters, which again, it's nice that we have those adapters. It's nice that we have these components that are in the sort of crayon box, if you will, the sort of, the palette full of colors. We have those options, but if we are just going to use RabbitMQ, or if we're going to use Apache Kafka, for example, then having to specify that for every single new communication relay, every single new interaction between components can become tedious. What I want is the flexibility to work in terms of messages. I want the flexibility to work in terms of of a message queue and to take advantage of all those benefits, but I don't want to have to write so much code that I end up regretting the decision to use messaging, right? So if we're willing to take for granted that we're going to use something modern and commodity like Apache Kafka or RabbitMQ or anything else for which we can find a binder, then we can use something called Spring Cloud Stream. Spring Cloud Stream builds on top of Spring integration. It features the same idea of a message channel through which messages are passed, but it makes a matter of configuration and convention the wiring of these components. So let's go ahead and build a simple producer here. Okay, we'll say producer, and the producer will be a web application. So we have a REST endpoint, and we're going to send some data in the REST endpoint to another service. So we're going to use Spring Cloud Stream. We'll use RabbitMQ stream processing here at start.spring.io. And we'll use the Activator because it's nice to be able to visualize. And we can use integration as well. We might we don't need the integration support here because Spring Cloud Stream and Spring Cloud Stream RabbitMQ bring in the minimal bits that we need to do the messaging. But it's nice to have the integration component set there if we want. Actually, we don't really need it for the producer, do we? We can get by without that. That said, that's our producer, and then let's generate a consumer, something that'll listen for messages and then accept the data and then do something with them. So we'll use H2, we'll use JPA. We'll remove the web support. We don't really need that anymore. And I think that'll do. That'll be. Oh, we can use integration for this. We'll use integration to use the Spring integration component model to respond to the incoming message. Okay, so there's that. Now, let's build a simple producer. Now, I have on my machine right now, I have RabbitMQ already running, right? So I've got RabbitMQ on my machine as we talk, and it's running in the background, right? It's running on another node, which we can get to. And what we're going to do is we're going to set up an application that produces a message whenever somebody calls a REST endpoint, and then we're going to write that message to RabbitMQ and then have it delivered to our consumer, all in terms of Spring Cloud Stream. So again, if you haven't seen the Spring integration video, then it'll be useful to understand what's happening there first before we get too far into the weeds on this one. You don't need to know about Spring integration, but it's nice to know about the full power that's sort of underneath the hood of what we're doing, because you can at any time drop down into Spring integration. So here we go. We have an application, and we're going to talk to another service. And the service, in this case, we're just going to call it consumer because it doesn't particularly have an interesting denomination. I'm not really setting up a particularly plausible example here. I'm just setting up a basic pub sub or producer consumer kind of exchange. So if we have another service and we want to talk to that service, we need to have a channel into which we can send messages. So let's first build a simple REST controller. Okay, we'll build a REST controller, and now when somebody goes to get mapping, we're going to say send a message. Actually, I guess we could just do a post mapping. What about that? Let's just do a post mapping, and we'll just accept a message at /. And so now, when public void publish, right? Here we are, publish. And what we're going to expect is a JSON structure of type map. Okay, so we're going to send a JSON body here. And what we want to do is we want to write that message whenever somebody makes a call to / greet. Let's just call it greet, and we'll pass in a parameter there, a path variable there called name. So whenever somebody sends a message, that's even better. We'll do that. We'll just send a message explicitly. That was very simple. We don't have to reason or think about it too much, right? So whenever somebody sends whenever somebody posts to this endpoint, we're going to send a message to somebody, right? We're going to say greeting equals hello name, okay? So now we want to publish that message to a downstream service, and I could, if I had a REST service, if the downstream service spoke REST, I could use REST in this case, right? I could use the REST template and then make a call to that service if I wanted to, but I don't want to really take that for granted. I don't want to take for granted that that service is available all the time. It may well not be available at this time, and if it isn't available, then I'm going to call a service that isn't there. I'm going to end up dropping state on the floor here, right? I need to guarantee that this data is eventually delivered whenever possible. So when we build sort of cloud native systems, we need to make sure that these things do the right thing, even in the face of topology changes and failures. And in this case, messaging is a better fit. So we're going to use Spring Cloud Stream. As I said before, we have Spring Cloud Stream RabbitMQ on the class path here. There are other binders that we could use, certainly, but we've got RabbitMQ on my machine. It works fine, so we'll use that. And in order to make this work, I need to define a connection to this other service. So we do this declaratively, do this using an interface. So I'm going to call this the producer channels interface. And the name is completely and utterly arbitrary. And what we need to define here is the message channels to which we would like to communicate. In this case, I've only got one channel, and the name of the channel in this case, because I'm lazy and I don't really have a more imaginative name, is consumer. That is the service that we're going to send a message to. It's our local logical perspective. This has no bearing on anything in the broker itself. This is entirely our perspective of the downstream messaging microservice. We don't care about RabbitMQ right now. We don't care about anything really. We just care about what are we doing in the code right now, right? This is a channel that's going to send a message out. So we're going to annotate this with @output. Now we could have multiple definitions here, right? In a microservices system, you might have different services that are set up and in service to different parts of the domain, parts of the business logic, right? So you might have a channel for the customer service, and another one for the order service, and another one for the fulfillment service, and another one for whatever, right? Different channels for different downstream messaging services. In this case, we've only got one, and we're going to call it the consumer. So there was that. Okay. Now, in order to activate Spring Cloud Stream, we say @enable binding, and we tell it about this interface definition that we've just created. And now this bean, this producer channels thing, is injectable. I can inject the producer channels and use it, right? So I'm going to create a constructor here. I'll create a constructor, and I'm going to inject the producer channels here. And remember, I'm using Spring Framework 4.3 because I'm using Spring Boot 1.4, and in Spring Framework 4.3, I don't need the auto-wired annotation, so I'll leave that off here. I'm trying to remember to do that. And all I'm going to do is I'm going to store the message channel itself, right? I don't care about the intermediate interface, but it's nice to know that I can get access to that if I want. So I can say this.consumer equals channels.output, or .consumer rather. And now I can send a message. So this is going to be a Spring Framework message. This is the very same type of message that you use if you use Spring Framework support for WebSockets, for example. It's all the message object and the message builder and all this and the message channel, all that apparatus came from Spring integration. And in Spring Framework 4, it was merged into the framework proper, right? So it's now part of Spring Framework, and it's been around for more than a year. So if you have Spring integration and Spring Framework on the class path, prefer the Spring Framework version of these types, right? Okay, so message builder with payload, and our payload, of course, is going to be a string. There's nothing fancy there. I'm going to then build it, right? So just building up a message. This is a builder, so I could set headers, for example. I could add errors and so on. I could add an error channel, but in this case, I just want to describe the message as quickly as possible. So this .consumer.send message. Okay. Now, we've written this entire application in terms of our logical use case, the logical thing that we're trying to do. We're trying to send a message to a REST endpoint and then send it out to the consumer service. We haven't thus far defined or made concrete what that means. What is the consumer service? To do this, we need to configure our application to talk to RabbitMQ, right? And we do this using convention. So remember, we have Spring Cloud Stream RabbitMQ on the class path, and the auto configuration, the Spring Boot auto configuration for RabbitMQ has been transitively added to the class path. So transitively, we're going to have a RabbitMQ connection factory, and I could specify the details for that RabbitMQ connection factory by using any of the well-known properties for Spring.RabbitMQ. So Spring.RabbitMQ.addresses and the host and the port and the password, all of this stuff. But the one we have by default, right? The one that we have by default here, Spring.RabbitMQ, which connects to localhost and so on, that will work just fine, right? So here's this. Okay, it's going to connect to 5672. It's already there. It's going to connect to a local host. You can see that here. So that's going to be enough. It's running on my local machine, but keep in mind that you should and could override those when you need to. What I do need to do is I need to define the bindings, though. So I say Spring Cloud Stream bindings dot consumer dot destination equals consumer, and this is going to correspond to a agreed upon rendezvous point in the RabbitMQ broker. So remember, in RabbitMQ, RabbitMQ is a little bit different, for example, than JMS. In JMS, you have a javax.jms.destination. A destination is a logical address, if you will, in the broker, upon which both the producer and the consumer need to agree. In RabbitMQ, there's a little bit of an extra indirection. There's something called an exchange in RabbitMQ, and if you send a message to the exchange, the exchange has the ability to then decide how to route that message to the appropriate queue. So the consumer connects to a queue, the producer connects to the exchange, and the handoff between the exchange and the queue isn't static. It can change later, right? You can change it in the broker itself, thus adding the ability to do extra kind of routing. And in fact, one of the most handy things you can do there is actually have RabbitMQ write the message from an exchange to another queue, which then gets routed to another queue, etc., all before it's ever delivered to the consumer. So you can add extra steps, you can add extra bits of indirection and processing, all within RabbitMQ and within the AMQP protocol. So we're going to send it to an exchange called consumer. By convention, this will turn into a queue on the other side. We're going to give it the same name, and it's going to use a routing key, right? It's going to use a routing key as well to figure out which queue it should talk to, right, from the exchange. All right, so there's that. Let's start the application on port 8000. There's this as well. That'll be enough, right? That'll be our simple RabbitMQ producer. Let's start that up. Okay, there's that. That should be enough. Now let's go ahead and look at our consumer, the other side of this equation, right? We have to go ahead and build a consumer that's going to take the incoming message from the producer, from RabbitMQ, and then just print it out. We'll just acknowledge the receipt of that message, right? So we'll say consumer application, and in this case, we're going to do the same thing in reverse. We're going to say interface consumer channels, and we're going to say at input. This is the reverse, right? So it's a message that will accept delivery. It's a channel that accepts delivery of incoming messages. And in this case, the channel name is whatever you want. We can actually just call this the producer if you want, right? So when the message comes in, we're going to route it to this channel, and we want to listen to that message. So let's say at enable binding, and we're going to say consumer channels.class. And then we'll define a Spring integration flow, right? This is my preferred way. I like doing this a lot. I like using Spring integration since I have a lot of background with Spring integration. But that said, there's also a component model you could use in Spring Cloud Stream, right? You can use a component model in Spring Cloud Stream to declaratively, wire a method invocation to the arrival of a new message. So integration flows.from. And we're going to take advantage of our newly created consumer channels, right? So there's this, and we're going to say c.producer handle, and what we want to do is we want to just accept the incoming payload, and the payload is of type string. So we're going to say string.class, and then we have to provide a lambda that will accept the headers and the payload, and it'll do something with it. And what we're going to do right now is we're just going to return null. Then we're going to create the pipeline, the flow there. And now we can revisit this now that we know everything's sort of wired together. So all I'm going to do is I'm going to log the incoming data, right? So I'll use a logger here, prototype. And if you saw the recent video on components that you can use inside of Spring Framework to make your code more Spring aware, one of the nice things that we have there is an injection point, and that's a very convenient object there. So what that lets us do is we can define loggers like this. So injection point IP return logger dot get logger IP dot get declared type dot get name, right? So there's that. And now we can inject the logger here as well. And we can just say logger.info new message payload. Okay, there we are. Okay, so now there's our consumer. It's going to spin up. It's going to listen for messages that are coming in on this input channel. And as soon as the messages arrive, we're going to pass it to this service activator, this handle method. And the handle method is going to simply print out the message that has arrived. Okay, so here we go. Spin that up. Okay, so this is up and running. Our other service is on port 8000. Let's go ahead and send a message to it. And we'll say, let's see, we want to line things up so we can still see what's happening here on the console. We're going to say curl -d, that's an empty HTTP post, to localhost 8000 / and I've already forgotten what the name of the thing was, greet name, so greet world. Okay, so we should see, if everything goes to plan, hello world. Okay. Ah, it didn't quite work, did it? We didn't see the message arrive because we haven't specified the consumer. Oh, we didn't see it. We didn't see it arrive because we haven't specified the consumer, the reverse configuration. So Spring Cloud Stream Bindings dot consumer dot destination equals, and what did we say over here for the agreed upon rendezvous point? Equals, well, this is the producer, the equals consumer, right? So we're going to agree upon sending a message to this exchange endpoint, and this could be, whatever. Actually, we could just call this greetings. Maybe we should do that. We'll call this greetings on both the producer and the consumer there. It doesn't really matter, right? That's just the agreed upon rendezvous point in the RabbitMQ broker. It doesn't, that can change if we want to. This is the Java channel. This is the message channel that we created in our Java code. So this can't change. This has to match what's in the Java code. But as long as both producer and consumer agree upon this, and they're both talking to the same RabbitMQ broker, then things will work just fine. So this is the consumer, and this will work, right? This is going to work just fine. We can start the application. Try again now. There's the message, right? It says, hello world. Things are fine, but what's going to happen if we set the port to be 0 and then restart this and start it a few different times, right? We're going to start a few different instances. I'm going to disable the single instance only thing here. I'm going to hit apply, hit OK, and then I'll restart my consumer. I'll create another instance of the consumer as well. So I'll have two of them running at the same time. So this one's on 51377. Here's another one running on port, well, I don't know. We'll see. Okay, so 51411 and 51377. So what I'm going to do now is I'm going to send the same message. I'm going to send another message to my producer, which is going to then publish the message. And we've got two consumers now. What do you suppose will happen? Hello world there on the consumer on one port, and hello world there again on another port. That's not quite what I think most of us were probably expecting, is it? We've broadcast the message to two different consumers, which is fine. Maybe that's fine. But if I'm building a system where I want to deliver the message to one and only one consumer, then this is probably not what I want. And instead of load balancing by adding more consumers to divide the work, I've duplicated the work. I've broadcast the work, and that's not what I want. So what I want to do in my consumer is define a group. Okay, so I can call this whatever I want. The name here, the group name, is completely arbitrary. This is a consumer group. And in Spring Cloud Stream parlance, that means that if I have one or more consumers in the same group, only one instance in that group will get any one given message. So it's exclusive to among the members of that group. The message will be delivered exclusively to one node. So I'm going to call this the greetings group, and we're going to go ahead and restart this instance here, and then this instance. Oh, whoops, wrong. That one there. Okay, there's this, and we'll restart this one. So now I've restarted both of them with this new configuration, right? Now, if everything goes to plan, we should see it. This is 51,469. This is 51,472. We should see the message delivered to one and only one consumer, right? We should see it on the console of just one node. So let's try again. Here we go. Okay. It didn't get delivered to this one. Hopefully it got delivered to this one. There it is. Hello world. So now our consumer group has done what we expected it to. Let's see if I make another call. Maybe it'll load balance for us. Yep. The second one got it, right? So we're effectively load balancing the work now. This is called work stealing, right? We can have as many consumers as we need. Another pattern, another name for this pattern is called the aggressive consumer, right? So what's happening is we're taking as much work as we can from the queue, but if we have more consumers, then we're able to divide our ability to handle that work, which is ideal if you're, for example, using Cloud Foundry. Okay, so we've looked at what happens if we have one or more instances of the consumer. What happens if we have zero? What happens then? How do we make sure that if we deliver a message that the message is processed eventually, even if there is no consumer? By default, this is not the behavior that we will have. So if we have 0 instances of the service available, then that message will sit dormant on the broker. It's still there. It's been acknowledged by the broker, but we don't have anything to take delivery of that message and to do something with it. So what we need to do now is to make our subscription durable, right? So we're going to take this here, and we're going to say producer.durable subscription equals true. Okay, so now we've got 3 attributes here for this producer channel that we've described in our definition here. Producer is this channel. Now we're going to say that the subscription is durable. So if we kill this and kill this, so both of them are gone. I have no instance here, goodbye, and I have no instance here. And now I'm going to send another message. I'll say hello world, durable world, right? We should see this now delivered on startup. I'm going to send the message. Oh, whoops. We're going to send the message, and I'm going to say, again, for example. So we should now have 2 messages that are sent to the broker, but not yet confirmed, not yet delivered. So we're going to start up an instance of this consumer, and we should see it retroactively consume the messages that have been delivered to RabbitMQ on the console here, right? There's hello durable and hello again. So it worked, right? We've successfully sent a message from the consumer, from the producer rather, to the broker and then to the consumer. But we've also taken care of, we've looked at how to do publish subscribe as well as point-to-point kind of messaging, and we've looked at how to build systems that do the right thing in the face of service outages and failures. After all, that is one of the big benefits of using a message broker, is the ability to store and then forward those messages. That gives us the ability to take down a service and still guarantee that everything gets processed eventually, right? We're now able to take down our consumer, if we need to, and upgrade it and deploy a new version or whatever, without losing the data. It's eventually consistent, right? We will eventually process the data, and the world will converge upon a well-known state eventually. So this has been a brief look at Spring Cloud Stream. Now Spring Cloud Stream builds upon Spring integration. In a later video, we're going to look at something called Spring Cloud Data Flow, which makes it dead simple to then compose or to sort of choreograph lots of small messaging-based microservices like this in support of stream processing, right? The sort of perpetuation of messages through a series of messaging-based services to arrive at a more complex result. Sort of like the pipes and filters model that you may be familiar with if you've used bash in the Unix command line shell. All right, thanks very much for watching, and I'll see you next time.